Okay, so let's start. So good morning, everybody. So, so in the last three chapters, the last three chapters are in the physical layer, in the communication layer or physical layer number one. So in this chapter and next chapter, we are going to talk about layer number two, which is data link layer. You should, from what I explained before, you should, as I said before, okay. So here in data link layer, anything I'm going to explain in this chapter and next chapter is actually going to be between two adjacent compute devices. Okay, it can be one computer and router. It can be router and router. Any two adjacent devices. It's not. It's only one hub, as I explained before, because this is the responsibility of layer number two. Layer number two is just between two adjacent devices. So here. Yeah, so as you know here from these layers, as I explained in the first chapter, layer number two, actually as you see here at the center side, layer number two is 6 data grams, as you see here, from layer number three. Okay, and put it into frames. So the word frame, we're going to use it in layer number two. Layer number three, we use the word data frame. Okay, so here at the center side, datagrams, the data received from layer number three should be stored in frames, and then as you see here, headers and trailers are added. After that, this layer has to send these frames to the layer number one, the physical layer, to transmit to the other side. At the receiver side, layer number two is gonna convert just a stream of bits, as you see here. We have just a stream of bits here. Out of this stream of bits, it has to create frames. So yeah, so what happens here actually, it has just ones and zeros. Okay, here at the receiver side. So what layer number two has to do, it has to identify the frames. Okay, so it has to, yeah, this is one frame, this is another frame, and for sure, I'm gonna tell you how this can happen. If you have just a stream of bits, how can you identify the frames? So again, you should understand, as I said before, take a seat. As I said before, in layer number one, in the first layer, there is no structure. So there are no frames, there are no packets, just a stream of bits. You got what I'm saying? So given a stream of bits here, the data link layer has to identify the frames, and it has to cut it into frames. Okay, for sure I'm going to explain how. Okay, so as I'm writing here, data link layer or layer number two transfers a datagram from the network layer of a node to the network layer of a physically adjacent. Okay, so anything, you don't need even to think about it. Anything I'm going to explain here between two adjacent computers or devices. Okay. Okay, so what's important is, so what kind of services provided by the link layer? Okay, the first service is framing, flow control, error control. Okay, also we have medium access control. So in this chapter, I'm going to explain these three: framing, flow control, error control. In the next chapter, I'm going to explain the medium access control. Is that okay? So again, don't be confused. Why? Because again, as I said multiple times, here in the link layer, anything I'm going to explain here just between two adjacent devices. Okay. In this course, we're not going to teach, it's not in the syllabus to teach layer number 4, the transport layer. But if you learn it anywhere, the layer number 4, you will find layer number 4 also has error control, also it has a flow control. You got what I'm saying? But there is big difference between the flow control here and the error control here, and between the ones at the transport layer. Why? because the transport layer is actually end to end, but this one hub by hub. So it's exactly the same thing, but here in this layer is actually I wanna achieve flow control between the end to end. But here I want to achieve it between every two adjacent devices. Okay. So here, so the first thing I'm going to teach here, framing. So what framing means, as I have just told you right now, what happens here, you receive at the receiver side, you just receive a stream of bits. You just receive 1 0 1 0 1 0 0 1 0 1, and then you have to cut it into frames. You have to create frames, and then you have to base. After that, after you create frames, you have to extract the datagrams. So you have to do the opposite of what you did here. Here you receive datagram, you put it into frame. Here you just have a stream of bits. It's not a structure. So you have to create the structure. How? That's what we call frames. You have to find the frames, you have to cut and stream of bits, you have to cut into frames. After you cut into frames, you have to extract the datagram and you have to send it to the upper layer. So the first thing I'm going to explain, how can we do framing? How can we identify frames? Okay. So here at the center side, we encapsulate datagrams received from the network into frames. At the receiver side, you have to convert the raw bit stream. The word raw here means it's there is no structure, just a stream of bits. It's not divided into packets or frames and so on. We are going to create frames out of this stream of bits at the physical layer. So you have to create a group of bits. We call it frame. Okay. As I'm going to explain for sure, a frame synchronization is for sure is very important. So what this means? It means you have to identify the beginning and end of the frame. So if you have, and that's what I'm going to explain right now in detail. So if you have just a stream of ones and zeros, okay, I'm going to tell you how this layer is going to identify the frames, okay, and it's going to create. So for example, I'm going to, this is one frame and this is another frame. How can we do that? The way, as I'm going to explain shortly, the way we are going to do it, we are going to use a special flag pattern. So we are going to use a special pattern, okay? Like for example, as you will see, 0, 1, 5 ones, okay, and then our 6 ones and 0. This is a special flag. So we are going to use a special flag, okay, at the beginning of the frame and at the end of the frame, so that after we receive just binary bits, so this layer is going to look for the flag. Okay, so as I'm going to explain right now. So this flag is just a special pattern. This pattern should tell me this is the beginning, this is the end. Okay. And for sure, this pattern, you have to put it here. So here, when you create a frame, I have to put this pattern here. Okay. Here, this should help me to identify the frame from just the stream of bits here. Okay. As I'm going to explain anyway entities. So the idea of frames is, given a stream of bits, how can you identify, how can you find the frames? I'm going to explain this one for sure. This is the first one. The second one, I already explained before, flow control. Flow control. The idea of flow control is actually basing between adjacent sending and receiving nodes. As I told you before, you have a computer or a device, you have another device here. What if this device it was actually much faster than this device? So one device should not overwhelm the other device. You cannot just send me data, okay? You cannot the speed of the generator should not be more than my ability to absorb or to process this data. Okay. So sending nodes must not send frames at a rate faster than what the receiver node can absorb. Okay. So that's what we call flow control. This may happen if the sender is running on a fast machine, powerful machine, and the receiver is in a slow machine. You got what I'm saying? So we want to do some kind of basing or synchronization somehow between the two computers. Okay. Can we control how fast is the data is sent from the sender? Okay. So the receiver should have some ability to control how fast you send the data. So if you send the data too fast to me, I have to notify you to reduce the speed because I'm not able to process the data fast. Okay. So then here I make it. Look here, I'm going to read this one. So flow control refers to a set of steps or procedures we take to restrict the amount of data that the sender can send. Okay, so anyway, we will see for sure. I'm going to explain different approaches for flow control. That's what I'm going to do in this chapter. Usually we do something, we call it feedback-based flow. Feedback-based flow. So the idea here, that's what we are going to explain in details. But the idea here is that the receiver sends back information to the sender, giving it a permission to send more data. That's why we call it feedback. I need the feedback from the receiver. Should I continue, or you are still processing what I sent to you? I should wait. So you have to send a feedback somehow using acknowledgement or negative acknowledgement, as I'm going to explain. So you need to send some data from the receiver to the sender to tell the sender, please slow down. What I'm saying? The negative thing here, error control. Error control. So error control here means, as we know from what I explained before, and this is very important to understand what we are going to explain here in this chapter. Look here. If I have a data something like 0, 1, 1, for example, 0, 1, 0. Okay, if you have a data something like that. Okay, so when you send, if you have a frame like this, like a very small frame like this one, and you want to send it from one node to another, okay, there are many things can happen. Don't think just it's going to be the same thing. No, there are many things can happen. Number one, the whole frame may be lost. This is one of the problems. Okay, so for example, I'm going to send frame number 1, frame number 2, frame number 3. Okay, so I think frame number 1, frame number 2, but frame number 2 was lost. You got what I'm saying? So this is a problem, right? So you need to identify, number one, you need to know if there is a frame lost or not. This is in the very beginning, okay? How can we do that? Very simple. I'm going to number the frames. Yeah, so in the header, I'm going to put this is frame number 1, number 2, number 3, and so on. So if I receive frame number 1, and then I receive 3, I then receive number 2, what it means? It means number 2 was dropped. Okay, so this is how I can identify if a frame is lost or not. Lost means it's dropped because it's just between two nodes, right? Nothing in the middle, just between two nodes. You sent a frame, and because of the channel impairment, okay, I was not able to receive anything. So this is a problem can happen. That's why we need error control. Okay, how we can correct this error, the lost frame. There is another thing here also can happen that maybe I'm going to receive the frame, but it is corrupted, okay, or there are errors or mistakes in the frame itself. What kind of errors that can happen here? For example, here, because as I explained also, I want to just link what I'm teaching here with what I taught before. For example, I explained before the synchronization problem. Maybe because of the lack of synchronization, here, this one, I'm going to receive it like 1, 1, for example. So that's what you are sending, but what I'm going to receive is going to be 0, 1, okay, 1, 1, 0, 1, 0, for example. Okay, so 1 bit, you sent 1 bit, it's going to be 2 bits. This can happen, okay? Or maybe 1 bit is going to be flipped. So you sent a 0, but because of the noise, I'm going to receive 1. All of these errors can happen. You got what I'm saying? So again, I can divide the errors that can happen. I can divide into 2 things. Number 1, lost frames completely lost. Okay, and that's why I told you we are gonna number the frames, number them, and based on the sequence number, the receiver can know if take a seat and don't make disruption. Okay, so at the receiver side, so we can know if a frame was lost or not from the number. Okay, damage. As I told you, damage. So maybe some bits are flipped, as I said. Maybe some bits are lost. So, for example, here 1 bit is maybe doubled, as I said before, because of the synchronization. Okay, or maybe you lost 1 bit completely. So all of this can for sure can happen. Okay, so number 1, I need a way. 2 things here, guys. Number 1, the receiver needs a way to know if there is a mistake or not. This is number one. Number two, once I know there's a mistake, I need to correct it. Okay. So as I'm going to explain right now, how the receiver can know if there is a lost, as I said, lost frame. I told you from numbers. So you have numbers, okay? So if I don't receive one number, so I can know this frame is not, I didn't receive it, right? So how can you know the frame is damaged? So there are some ways to, once you receive some bits, this is out of the scope of this course, but there are different ways you can do some calculation to know. I'm not sure if you in network one, I'm not sure if you were told about like the parity, how the parity bit can be used to identify. Yeah, I find some errors. For sure, that's a very easy way. The parity is very easy. There are more advanced ways. But anyway, so there are, yes, when you send your data, you send something, we call it CRC, okay, which some bits here you can use it to verify to see if the data, there is error in the data or not. So again, once you know if there is error or not, you need to correct it. You need to correct the error, okay? And the way we are going to correct the error here is very simple. The way is retransmission. So once I find error, I'm going to ask the sender to retransmit the data again, okay? And again, as I'm going to explain to this, you will see something like acknowledgement, negative acknowledgement. So when I see acknowledgement here, positive acknowledgement. When I say negative acknowledgement, okay? So when you send a frame, you can send me acknowledgement, received, send the next one, and then I can send the next one. You can send a positive acknowledgement, just yes, I received it. Okay, or if you didn't receive it, you can tell me he sent to me negative acknowledgement. Tell me I didn't receive frame number, so I need the feedback from the receiver. That's what I'm, again, this is just an overview. So that's what I'm going to explain into. So in this chapter, I'm going to only focus on framing. I'm going to focus on flow control, error control. I'm going to teach different approaches for that. Next chapter, I'm going to talk about one of the tasks of layer number 2, which is medium access control. Okay, so and simply what this means is, you can tell from the English name, we have a medium. What do you mean by medium? Okay, for example, in case of bus topology is a medium. We have here a bus, and then several computers can access the bus here. Okay, so the medium here is the bus. All of us share the same medium. In case of if you use the air, if you transmit through wireless, so all of us share the same air. Okay, so what happens here? Here we use bandpass, because we are using bandpass. Only one computer can use the channel at any time. Only one computer can use the channel at any time. So if computer A decided to transmit, okay, so computer A is going to use the whole channel. So the whole is going to use the whole bandwidth. Okay, as I explained in the bandwidth. Okay, so if computer A decided to transmit, no one else should transmit. Otherwise, if it happens, two computers transmit at the same time using the same frequency, that's what we call collision. I'm explaining that because as you know from broadband, two computers can transmit at the same time. It's okay because we use different frequencies. Okay, but here in our case here we use bandpass. So only one can use a channel at a. We're not gonna divide the bandwidth here and everybody can use. No, if only one can use the channel at a certain time. So we need some kind of coordination. We need coordination here because if you transmit and also I transmit, the signal is distorted. You didn't use the channel, I didn't use the channel. We lost the channel. Okay, we lost it. We lost this time. No one was able to transmit because your transmission was distorted by my transmission. So we need a way for a mechanism for coordination. We need to decide who should use this channel right now. Okay, you can go first. You can use the channel after you are done. So I'm gonna go after you, but we cannot transmit at the same time. This is the meaning of medium access control. There are different approaches for that. We are gonna teach this approach. We are gonna compare between them, and this is the topic of next chapter. So let's start first with framing. Okay. So again, what framing means? if you have a stream of bits, how I can identify the frame? Very simple. How we can identify the frame. So I'm going to tell you here, and what. So here, framing, we may at the receiver side, as I told you, you have to map. You have to cut a bit stream into frames. You have just a bunch of bits. You have to find what is the frame and cut it into blocks. Every block is that's what we call a frame. Okay. At the sender side, actually, we may need to decide what if the second layer receives like a very large data from layer number 2. Okay. So in this case, so layer number 2 is giving like a very large data or very big data coming from layer number 2. Layer number 2 is coming to layer number 2. So in this case, layer number 2 can do some kind of segmentation. Okay, so segmentation here means, and I'm gonna cut it into small pieces. I'm not gonna transmit the data received from layer number 3. I'm not gonna transmit it into one frame. Okay, so it may happen if I receive very large data from layer number 3. Okay. If I receive large data from layer number 3, so maybe I'm gonna cut it into small pieces. I'm gonna put, so here maybe I'm not gonna put everything in one frame, but I'm gonna use 2-3 frames because, and the reason there are several reasons here. Number one, maybe the buffer size. Why it's a good idea if you have a big data, just or very large size of data, you are gonna cut into small pieces. Instead of one frame, I'm gonna send multiple frames. Okay. There are several reasons. I listed the reasons here. Number one, maybe the buffer or the memory at the receiver is not that big. So if I transmit very big data to the receiver may not have a space to store it. Okay. So if I cut it into small frames, small data, for sure it will be better. As I explained before, it may be if you transmit like a large block, so the probability of error is higher. Okay. Also, if there is an error and you need to retransmit, if I have a small data, it's gonna be easier because you're gonna retransmit a small amount of data instead of a large amount. Not only that, if we have a shared, as I said here, a shared medium. If you transmit a very long data, so one computer is going to occupy the channel for a long time. And that's not good for the others, because the others also want to transmit. So it's not good for sharing. If you want to share something, okay, it's very bad for sharing that one computer is going to use the channel for a very long time. That's why it's a good idea in layer at the sender side, if you receive a very large data from layer number 3, to cut it into, I'm not going to put it in only in one frame. I can put it in multiple frames. Okay. So again, I'm going to explain now different approaches. How can you identify the frames? Because simply you have just at the receiver, you are going to just receive 10 10 10 10, and then you have to cut it. You have to cut into blocks. So how I can identify the blocks? How I can know what is the beginning and as the end of each block. So I'm going to start with a very naive ideas, because if you understand why these ideas are very naive, you will understand why we are going to solve it in a different way. So the first naive idea is, so here this link has to back. It has to back the bits into frames. Okay. And there should be a way to distinguish the different frames. Okay. So now number one, let's start with the very naive way. The very naive way is we can have fixed site framing. Okay. So now all what you have to do is after you receive the stream of bits, for example, I receive 1 0 1 1 1 0. Okay. So I'm gonna tell you every 5 bits, 1 frame. Okay, very easy. So all what I'm gonna do is 1 2 3 4 5 frame. 1 2 3 4 5 frame. 1 2 3 5, for example, frame, and that's it. You understand what I'm saying? You can do this way, but this is a very naive idea. Can anybody tell me why this is not a good idea or very naive idea? Simply, what happens if you lose 1 bit? everything it's not going to work, right? So what's going to happen if the transmission is perfect, or there is no noise, okay, yes, this is a good idea. However, what happens here is, what if you lose one bit? If you lose one bit, what's going to happen? So it's going to be difficult to synchronize again, because once there is one error, so all the coming frames are wrong. Once there is one error here, all the coming frames are wrong. Okay. So another idea, I can make it like variable size frame. So size is variable. Okay. But in this case, you can put the count here in the header. So here, as you see, for example, here, this is the header. In the header, I'm going to say this frame is 5. So 1, 2, 3, 4, 5, it's frame. Next one, here in the header, I'm going to say 5. 1, 2, 3, 4, 5, it's a frame. Here I'm going to say 8. 1, 2, 3, 4, 5, 8, and so on. You got what I'm saying? So in the header, I can say, I can use some bits here. I can use some bits in the header to decide how big is the frame. You got what I'm saying? Again, what's better? It's the same problem we have here. What if, for example, here, for example, instead of 9 here, 9, 1 bit flipped or 2 bits are flipped. Okay, so what's going to happen? This number is going to change, right? So instead of 9, this number can be, for example, 6. So what's going to happen? 1, 2, 3, 4, 5, 6. So this will be a frame. And then I'm going to think this is a new frame. You got what I'm saying? I'm going to think this is a new frame. And then so once a mistake happens only one time, all the coming frames are wrong. So this is, again, very naive idea. So what is a good idea? Okay. Again, what do you mean by good idea? The good idea means if you make a mistake for one frame, you should be able to correct yourself after that. Okay, and this is not the case here. This is 5, I'm going to take 5. It's okay. This is 5, I'm going to take 5. So it's okay. But this one, well, then what I want here, this one was here, and because of the noise, then it's 6. So now it's 6. And then after everything after that, it's going to be wrong. You know what I'm saying? So anyway, so the better idea is, every frame, this is a frame here, okay? Header and trail. So here I'm gonna put a special pattern. I'm gonna call it a flag, and then I'm gonna end it with a flag. This flag is actually 0 is a special pattern, something like that. 0, 6, 1, 0. Okay. So that what happens if I lose, if a mistake happens here? Okay, so this frame will be wrong. But it's easy to resynchronize. Why? Because I'm going to look for the first next flag. Okay, so it's going to be easy to synchronize. Anyway, I think you can easily move to look for the next flag once you have a mistake here. Okay, but there is a big problem here. It may happen. The big problem is that you are going to use a special character. Okay, this special character, we call it delimiter. I'm not sure if you should be familiar with this term in programming. We use it in programming, delimiter. Delimiter is like a special character. Okay, so here I can use a special character here, 6 1s, okay, and 0. Okay, so this special character, we call it flag. This should tell me this is the beginning and this is the end of the frame. Okay. So once you have a stream of 1s and 0s, I'm going to look at these flags. By using these flags, I can know this is a frame, this is a frame, this is a frame, by looking at it. But the question is that what happens if by accident, because you have just the data here, what happens by accident, this flag was repeated here. You are receiving some data. So this flag was here. The same pattern, 0, 1, 1, 1, 1, 1, 0. So this pattern was here. Okay, what's going to happen in this case? What's going to happen at the receiver side? You may think this is a flag, and then you are going to lose this frame, okay? Because you will think. So, in order for this idea to work, I have to make sure this flag, it should not happen here. Okay? How can you make sure of that? Very simple. We use a technique, we call it bit stuffing and bit unstuffing. Okay? So the idea here, every time we have 5 1s. Every time there are 5 1s, we are going to put extra 0. We are going to put a 0 to the data. So I'm going to change the data. So every time there are 5, I'm going to put 0. Every time there are 5 1s, I'm going to put 0. Why? Because I don't want to have 6 1s. 6 once, it means a flag. Okay. At the receiver side, you otherwise you change the data. I have to put the original data there. How can you do that? Every time I take a C, every time I find once, I'm gonna remove the zero. You can see. So again, I have to make sure this flag should not happen here. How can you make sure this flag is not going to happen here? Otherwise, you may think this is a flag. How can you make sure of that? Every time there are 5 ones, remember the flag 6 ones, 6 ones. Every time there are 5 ones, I'm going to put 0. You got what I'm saying? Even if after the 5 ones, if there is already 0, I'm going to put another 0 here. That's what we call stuffing. Okay. And the receiver, you have to remove these extra zeros. I just put this 0 to avoid making mistakes. Anyway, I think that's enough for today.